Okay, let's do another numerical. Said in the example, it said calculate the transconductance and output resistance of common source stage amplifier. So this is the figure where this is common source is common to input terminal and output terminal. So common source stage amplifier. So amplifier, this is the input terminal where V in input signal is given. The equivalent AC equivalent small signal equivalent circuit is given here. Here V in the input is given. Now when we will draw the equivalent circuit, we always ground the DC source. So if we, but here input is a small AC, so input signal Vin is there. This is your gate, this is source, and this is the drain terminal. Now if we draw the equivalent of the NMOS, then there is a dependent current source GMVGS, equivalent resistance, output resistance RDS, and here you can see that there is a source resistance across the source terminal. Within the source and ground terminal there is this RS. So due to that a body effect will come across. So if we see this is fine, if we consider this is Y terminal, then potential drop across here, this will be your VBS, the potential drop between the source and body. So current is passing through in this direction. So VBS equals to, we can write minus VSB equals to the I out will divided in 3 branches, then these 3 branches will be added, current will be added, so I out current will passes through RS. So I out into RS, this negative, so this current will passes through that. Now if we see the input V in equals to what? V in equals to the potential difference between gate and body. The gate and source is VGS plus the source and body VSB. So we can write VSB nothing but VBS. So VGS minus VBS equals to VGS minus I out into RS. Okay, you can write that. Now in this part, if we apply KCL in this part, then this output I output current I out is divided in 3 branches, this branch, and this branch. So I out equals to GM VGS, okay, plus what? GMB VBS, okay, plus the current passing through this branch. So this is current passing through how much potential difference between this RDS, that is this terminal is connected to ground and this terminal is connected to Y. So the potential difference between these two, Y and body, that will be the potential difference between the Y and the ground terminal here. So here the potential drop is how much? The VBS potential drop VBS. So this VBS by RDS. Now here the current is passing through this terminal to this terminal. So this terminal is positive, this terminal is negative, but when we are calculating VBS, then VBS source, this terminal VS, this is S and B. Okay, so VBS equals to minus VSB equals to minus I out into RS. So if we replace this, so we can write GM. What is VGS? VGS equals to here we can write also VGS equals to what? This VGS V in minus, sorry, VGS equals to, this will come across here, this is V in equals to VGS minus I out into RS. So VGS equals to V in plus I out RS. Okay, so we can write here this GM into V in plus I out into RS. Okay, plus GMB into VBS. VBS equals to what? Minus I out into RS. Okay, this is plus terminal, VBS equals to minus I out RS. So we can write minus I out RS by RDS. Okay, RDS. So finally I out, sorry, this is small, we have written there, out equals to GM V in plus I out GM RS plus, sorry, minus, plus minus minus I out GMB RS minus I out RS by RDS. Okay, now after that, if we find out, if we simplify this, then we can, from there we can find out I out by I V in, I out by V in. We know transconductance CE. If we take GM of this amplifier, GM equals to I out by B in. Okay, so now from this we can find out I out by V in. I out, if we take common one side and then do that, then finally we'll get I out by V in. Okay, that equals to GM by 1 plus GMRS plus GMB RS plus RS by RS by RDS. So this is the final GM by 1 plus GMRS plus GMBRS plus RS by RDS, the final transconductance equals to GM. Now if I want to find out the output resistance, so this we have to calculate transconductance, we have find out transconductance, and we have to find out output resistance. So if I want to find out output resistance, then what we have to do, we have to apply a Now simplify this figure. You have to apply a potential supply across the output terminal. Then if we do V out by the current passing through I out, V out by I out, then we can find out the output resistance. Now if we simplify and then so this is the equation where we have applied at the output terminal a potential Vx. Now if we find out Vx by Ix, that is your the Rx, that is nothing but R out. So we have to find out output resistance. So gate terminal is shorted with ground, and at the output drain terminal, this is your drain terminal having a supply Vx is given. So Vx by Ix will get Rx, that equals to R out. So now how much current is passing through RDS? Current through RDS equals to Ix, this current minus this current and this current. So Gm VGS minus GMB VBS. Okay, what is VGS? VGS equals to Ix Rx. VGS source terminal is connected to ground through a resistor Rx, so potential drop across here, that will be the reverse potential across the Gs. This gate is connected to ground, source is connected to this terminal, so across this potential drop, that will be the reverse potential will come across the gate and source. And VBS equals to what? Ix minus Ix Rs. We have previously calculated the same way. So IRDS equals to what? IRDS equals to Ix minus GM VGS, that minus will plus, so plus GM Ix into, sorry, this is VGS Ix into Rs, so Ix into Rs plus GMB VBS Ix Rs. Okay, so from there IRDS equals to Ix, if I take common, 1 plus GM Rs plus GMB Rs. Okay, from there if I want to find out the Vx total potential difference across applied across here, Vx equals to this RDS into IRDS. So this, if I want to find out Vx, that equals to IRDS into RDS, this potential, this current RDS is passing through this RDS, so potential drop across this RDS is into equals to IRDS into RDS plus what this potential drop across here, that is Ix into Rs. Okay, so here if we put IRDS value of that, from there we can find out. Now if I put Vx equals to IRDS equals to what? Ix into 1 plus GM Rs plus GMP Rs into RDS into RDS plus Ix RDS plus Ix Rs. You can write Vx by Ix equals to what? Ix taking common, so I can write 1 plus GMRS plus GMBRS into RDS plus RS. So R out equals to 1 plus GMRS RDS plus GMBRS RDS plus RS. If we simplify, then we can write this RDS is common here also, sorry, so this RDS will come across here. Okay, so finally you can write R out equals to RDS plus GM RS RDS plus GMB RS RDS plus RS.